So we talk about the decimal and 0 and 1 and how to convert the decimal to binary and how to convert the binary to the decimal, right? And how to count the binary. And today we are going to learn more, which is only happened on the binary operations. Sometimes we call the bit operation. The bit means 0 and 1. Okay, because as we talked about in the first lecture, the computer, original computer only takes 0 and 1. Okay, that's called bit. Okay, so bit is actually the smallest unit in computer. So this is 1 bit. So this 1 bit only takes 0 and 1. So this is 2 bit. This is 3 bit. This is 4 bit, etc. Okay, so the bit is the smallest unit in computer. So 1 bit only takes 0 and 1. All right. So and also we hear like byte. Byte. Sometimes we know it's capital B, byte. So anybody know how big is 1 byte equal to? Anybody know? Anybody know? 1 byte equal to how many bits? Nobody? So 1 byte equals to 8 bits. Okay. Yeah, that's right. So 1 byte equals to 8 bits. So basically you have, all right, you have 8. You have 8. So what is the biggest number you can use byte to represent? What is the biggest number you can represent using a 1 byte? So we learned the binary in the first lecture, right? What is the biggest number? If we're talking about both positive number and the negative number, if we're talking about the both positive number and the negative number, so usually the first number is the sign of is the sign, right? It's a negative value. If it is 0, it is positive value. If it is 1, it's negative value, right? So the first one is the sign. Okay, 0 means positive, 1 means negative, and you can use these 7 numbers to represent the numbers. Okay, so basically the biggest number is 0, 1, 1, 1, 1, 1, 1, 1. You have all ones. Okay, you have all ones. So basically is what? Is 2 to the power of 7 minus 1. Okay, which equals to what? Okay, 2 to the power of 7 minus 1. All right, so this is the biggest number you can use to use 1 byte. And now we talk about, so usually we talk about your memory. We are talking about your memory. 1 megabytes. 1 megabytes is equal to 1,000 kilobytes, right? 1,000 kilobytes. So this is kilobytes, 1 kilobyte. So for example, how big is your file? So you can right-click one file and check the size of the file. If the file is 1 KB, it's kilobytes, which means 1,000 bytes, right? So that means 1,000 bytes. So that's how big your file is. So 1 KB is 1,000 bytes, which is equal to 8,000 bits, right? You can think about, you have like 8,000 of these. You have 8,000 of these to store a file, all using 0 and 1. You use those to store a file. Okay, how big is your memory? So let's say my memory is 1 gigabytes. 1 gigabytes. So that means 1,000 megabytes. Okay, 1,000 megabytes. But today we are going to talk about the bit, which is the smallest unit in computer science. All right, smallest unit in computer science. Okay, so let's continue. So this is how we count the binary 0, 1, 1, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, etc. Right? We learned this in the first lecture. If you forget some of the topic, you can go to my YouTube to review. All right. So this is the okay. And now we're talking about the logical operators. If you learn any programming language, you will see these. Right? You will see this and. If you learn C++ or Java or C#, you will see this and. If you are using the Python, you will see and, right? It's an English word, and you will see or in C++ and Java, and you will see not using this sign, okay? But in Python, it's kind of different. You will see and, you will see or, you will see not. So basically, this is called logical operators. So let's see if you have, so if you have something and you have using the and, if you are using the Python, and or if you have this and sign here. So basically, this is what we call the conditional check, right? Conditional check or conditional statement. Basically, this is a Boolean value. Boolean value. So Boolean value means this value is true, either true or false, right? Either true or false, only two cases, only two values, true or false. And this also is true or false, okay? So for example, let's say, if you got 90 points, if you got 19 points in your final exam, and if you got 90 points in the final exam, and tomorrow is a sunny day, you can go outside to play, okay? If you can get 90 in your final exam, and tomorrow is a sunny day, you can go out to play, okay? You can go out to play. So how about I got 95 and tomorrow is a sunny day? Tomorrow is a sunny day. Can I go out to play? So your parent statement is, if you got 90 in your final exam and it's a sunny day, you can go out to play. And the truth is you got 95 and tomorrow is a sunny day. So can you go out to play? Yes, you can go outside to play, right? You can, because this is true. This satisfies this 90, this is true. And this is sunny day, it's also true. So this is true, and we are using the and. So you can go outside to play, okay? So how about this? How about you got 98.5? You got 89.5, you got 89.5. And tomorrow is a sunny day. Can you go out to play? No, sorry, you didn't satisfy this condition. You got 89.5. You didn't satisfy this condition. So this is false, right? And this is true. But when you use and, so that means both condition has to be true. And this condition, the whole thing will be true. All right? So 98.5. Okay? So that's why you have to satisfy 90 and this. Both condition has to be true. Then you can go outside to play. So this means the and. All right, this and, or in Python, you will see the and, okay? All right, so how about you got 90, you got 100, but tomorrow is like raining. Is it going to be rain? Can you go to play? Can you go outside to play? No, right? Both condition has to be true. You can go outside to play. So both condition has to be true, all right? So basically this is the and. How about the or? How about this or? So your parent says, if you get above 90 points, or you can go out to work. So for example, you are going to find a job in Walmart, okay? You find another Walmart, you find a job in McDonald's, and you can earn $1,000, okay? You work in the summer, you find an internship in McDonald's, and if you can earn $1,000, if you can get 90 in your final exam, above 90 in your final exam, and or you can earn 1,000 in the McDonald's, your parents are going to give you an iPad. All right? Okay, so this is the condition. If your final grade is above 90, or you can earn 1,000 in the internship, I'm going to buy you an iPad. So now your final exam is, 59, and you earn 1,200. Is your parent going to buy you an iPad? Yes or no? Yes, your parent is going to give you an iPad. Okay, although you got 59, a pretty bad grade in your final, but you earn 1,200. So your parents can give you an iPad. The parent will give you an iPad because the condition is connected by an or. So one condition is true, then it will be true. Okay, one condition to be true, then it will be true. All right, so how about this condition? How about you got 59? Oh, sorry, you got 89. You got 89, and you earn 999. 999. Is your parent going to give you an iPad? No, your parent will not give you an iPad because this condition is false and this condition is also false. So your parent will not give you an iPad. All right, both condition has to be true. Both condition has to be true, then your parent will give you an iPad. So this is called or. All right, and then this not, the last one is not. Not means I'm going to switch the sign. If it is true, I'm going to switch to false. If it is false, I'm going to switch to true. Okay, so this one is simple. So usually, how do we it's very simple, right? So, but if you don't understand at the very beginning, we can call this true table. All right, okay, you just memorize this true table. You can see if you have if you have and, so this is x, y. So basically this is x and y, all right? And this is evaluation. This is the evaluation, okay? So if the x value is false, if the y value is false, and x and y is false, okay? So this means x and y, I'm going to get false. If x is false, y is true, still getting false. Only when both true, the x and the y is true. All right, only this case, only x and the y both true, both are true. X and the y are going to be true. All right, the or means if I have one true, I only need one true, then I'm going to get the true. If both true, of course, if both true, I'm going to get the true. All right, so this is called the true table. And the not is very simple, just the reverse. If it is false, reverse to true. If it is true, I'm going to reverse to false. So this is called the logical operators, okay? If you're familiar with any programming language, I'm pretty sure you will see this all the time, all right, all the time. So now let's go back, let's go to the bit operations. So the bit operations is very, very similar. It's very, very similar to the logical operators, okay? They also have not, they have and, they have an or, and they have one additional one called XOR. I'm going to explain this XOR. So they have for, not is the same thing. So the notation, usually the notation in the exam, you will see not A, okay? So this A is conditional statement, is the true or false. So not A, so if the value of A is true, not A is going to be false, okay? Sometimes you will see this. Sometimes you will see this. You will see a sign of the this and the A. So this also means not A. It's just a different notation. And sometimes you will see this. It's a bar, okay? It's a bar above A. It also means not, okay? It also means not, okay? So, but this is bit operation. The bit only has two values, 0 and 1. So when you see a 1, so that means true, okay? When you see 1, that means true. When you see a 0, oh, sorry, so I have to change this. When you see a 0, this means false, okay? This is very important. When you see a 0, that means false. Then anything, other things are the same as the logical operators, okay? Other things are the same, okay? So this is not, this is and. So this and, usually you only see one and. In bit operations, we only see one and, not two and, okay? It's one and. Or you will see and. Oh, sorry. And in the ACSL competition, you will see just the and, English word and. Or sometimes we will see one and or is like one or, okay? One bar here, one bar here, okay? So this is or, the same thing. So you can see x and y. When x both 0, it's gonna 0. When x and y has one 0, it will be 0. Only when x and y both 1, you are going to get 1. This is and. And the same thing for or. If you have one, okay? If you have 1, you can see here is 1, here is 1, here I have both 1. If you have 1, you are going to get 1, okay? You are going to get 1, okay? And the not is very simple. So not is not, I'm just going to, not x, I'm just to flip this sign, right? Flip this sign, okay. The last one is called XOR. XOR, you will see different notation. Sometimes you will see XOR, sometimes you will see this sign. I don't know the English name for this sign. And sometimes you will see this sign, okay? So this means XOR, you will see A, this sign B, so that means XOR. Sometimes you will see A, and this sign B, that means XOR, okay? The same thing, same thing. This means XOR. What XOR means? XOR means when X, Y, they have different value, okay? If X and Y, they have different value, you are going to get Y, all right? If they have different value, you can see X is 0, Y is 1, you are getting 1. When X is 1, Y is 0, they have different value, you are going to get 1, all right? If you have same value, 0, 0, you are going to get 0. 1, 1, you are going to get 0. All right? You just memorize this. When they have different values, you are going to get 1. If you have same value, you are going to get 0. All right, so this is XOR. This is XOR. Okay, so the bit operations has four operations. Here has 4 operations, and later we are going to introduce more operations. All right, so the logic are almost the same as the logical operators. So this, but they have additional one called XOR. Okay, and 1 means true, 0 means false. All right, it's pretty simple. Okay, so any question here? Any question? All right, so if you don't have questions, we will see some examples. Not example, it's very simple. Okay, so you will see not, or you will see this squeeze sign or something, or you will see a bar here. That's the same thing. Okay, so basically this is 101, 110. Basically, I'm going to just flip every digit. This is 0. I'm going to flip to 1. This is 1, 1, 1. I'm going to flip to 0, 0, 0. And this is 0, 1. This is 1, 0. It's very, very simple. All right. And this sign is the same thing. 101, 010. Okay. 110, 001. And this is the same thing. It's just a different notation. Okay. They represent exactly the same thing, just a different notation. All right. So this is not example. And we will see something. Sometime you will see this. Not, double not. Okay. Negative. So if you see 2 bars, the not A is equal to A, right? It's very, very easy. So if you see not A, so if A is true, if A is 0, not A is going to be 1, right? And then not A is going to be 0 again. If A is 1, not A is going to be 0, and not A is going to be 1 again. So not A is going to be same as A. All right, so it's pretty simple. So if you see not this, is exactly the same thing. All right, so this is pretty simple, right? Okay, so this is not example. The next one is the AND example. Sometimes we will see this sign, AND example. So in bit operation, the easiest way you just write 2 values, 101, 1011. Okay, and you can see this one we have 7 numbers, but this one we have 6 numbers. So you have to align on the left to the right. You have to align 2 numbers to the right. Okay, align. You have to align this to the right. Don't get it wrong. You just think 123, and you have 45, right? So this is unit digit. You have to align the unit digit. The same thing happens here. So this is the first digit. So you have to align on the right. You have to align these 2 numbers. If they have different lengths, you have to align these 2 numbers to the right. Okay, it's the same thing. 123. If you use 123 plus 45, you have to align them on the right. Okay, and then you just do bit operation. Bit means, okay, you are going to pair them together. You are going to pair them together. So this is 1 and 1. I'm using the AND operation. So 1 and 1 equal to 1. 1 and 0 equal to 0. 0, 0, 0. 1, 1, 1, 1, 0. How about this? How about this? So if you have less digit here, it always means 0. Okay, it always 0. It always means 0. So this is 0. So then this is 0. Okay, so this is 0. And then you can see 0. Oh, am I right here? 0. Oh, I'm missing one. I think I'm missing one number here. This is not correct. I'm going to fix it. So the number should be 0, 1, 1, 0, 0, 1. Okay, 0, 1, 1. Yeah, 0. I got it wrong. Yeah, I got it wrong. Right, let me fix it. 0, 1, 1. Okay, so that's the result. So first you just align. First you just align to the right, and then you just do the bit operation by every single digit. Okay, every single digit. Okay, so this is the AND operation. All right. So any question? If you see 1 is longer, 1 is less. So let's see if you see some. This one, I'm going to. How about this? So what's the value of this? So it's going to be 1, 0, 0, 0, and this 1. You can ignore this 2. You can ignore because this is 0, this is 0. I'm using the AND operator. It is all 0. Okay, then it becomes 1, 0, 0, 0, 1. All right, so this is AND example. Okay, so now let's go to the next slides. Okay, so AND example, they have the commutative law. Okay, A and B same as B and A. Okay, A and B same as B and A. Okay, so they have the commutative law, and also they have the associative law. If you have A and B and C is equal to A and first, I'm going to do B and C first, and then I'm going to do A and this result. Why? Because you can see if I have 1, 0, 1, 0, 0, 1, this is my first number. If I have 0, 1, 1, 0, 0, okay, you can switch the order, right? Because I'm going to do the AND on every bit. 1 and 0 is same as 0 and 1. So if I change the order A and B or B and A, it doesn't matter. So that's why they have the commutative law. And also the same thing, if you have 3 numbers, 0, 1, 1, 0, 0, 0, okay? So you can see if I have this, only this will be 1. Every others will be 0 because this one, all the digits are 1. This one will be 1. So if you look at this, if I'm using 0 and 1, it becomes to 0 already. 0 and anything will be 0, okay? So only 1, 1, 1 will be 1. So this also have the associative law. All right. So this is for the AND. All right. So now we are looking at the OR. So OR is the same thing. I'm going to write 1, 0, 1, 1, 0, 1, 1. And the second is 1, 0, 0, 1, 1, 0, 0. Okay. So that's same thing. I'm going to align to the right. Okay. Sometimes I don't need to write this 0, 0. If this number or this number, the same thing, right? Then I'm going to do every single bit. How about this two? How about this two? Because they do not have 0, 0. So I can fill in with 0, 0. And then I'm going to get this 1, 0, 1, 1, 0, 1, 1. All right. If you are missing some numbers in the front, you just fill in with 0 or 0. Okay. Exactly same thing as 123 plus 45. So this one means 0, right? You can just add them together. So this is the OR. Okay, so this is OR. So the OR is also support the commutative law. Okay, A or B is equal to B or A, and also it also supports the associative law. Okay, A or B or C, you do this A or B first. The same thing as you do the B or C first, and then do the A. Okay, they support the commutative law and the associative law. All right, so this is the OR example. And the XOR example, exactly same thing. All right. So you have 1, 0, 1, 1, 0, 1, 1, and you have 1, 0, 0, 1, 1, 0. Okay. When they are different, it's going to be 1. When they are same, it's going to be 0. So this is different. It's 1, 0, 0, 0, 0, 1. Oh, my result is wrong again. Okay. My result is, oh, sorry. Let me see. My right numbers wrong. Yeah, I think my result here is wrong. Yeah, I'm missing. So fixing those, copy paste those 1, 0, 0, 0, 0, 1, 1. Okay. Okay, I will double check after this session. I will make sure my slides is correct. 1, 0, 1, 1, 0, 1, 1, or 0, 1, 1, 0, 1, 0, 0, 1. This is 0, 1, 0, 0, 0, 0, 1. Yeah, this is correct. All right. So you just do the XOR operations on every single digit. So the XOR means when the numbers are different, it's going to be 1. When the numbers are the same, they're going to be 0. All right. So this is XOR. All right. So the XOR also supports the commutative law and the associative law. Okay. They're also okay. So let me ask you one question. So if I have a lot of numbers, so let's say 0, 1, 0, 1, 0, 1, 1. So this is the first one, and 1, 0, 1, 1, 0, 0. And the first, the 0, 1, this 1, 0, 0, 1, 1. Okay, this is 1, 0, 0, 0, 1, 1. Okay, so if I have a lot of numbers, when does my result, and I do the XOR for all of them. When will be this number be 1? And when will be this number be 0? When? So actually, it is wrong. So this one is actually, this is 1. This is actually 0. This is actually 1. When the result for this digit will be 0, when the result will be 1. If I have a lot of numbers, how can you tell? How can you tell it is 0 or 1? In a faster way. Of course, you can evaluate one by one. Okay, for example, if I evaluate one by one, this 2 is going to be 1. And I'm using 1, XOR 1 is going to be 0. Right? And then I'm going to use 0, XOR 0, I'm going to be 0. Right? This is the same thing. 1 XOR 0 is going to be 1. And the 1 XOR this 1 is going to be 0. And the 0 XOR this 1 is going to be 1. Okay? I can evaluate one by one. Is there any faster way I can tell each digit is 0 or 1? Is there any faster way I can tell if I XOR all the numbers? Is there any faster way? So for example, for me, this is 1, this is 0, this is 0, this is 1, this is 1. I can do it really fast. Why? Anybody can tell? Or can you find any pattern? If I have a lot of numbers, let's say I have 100 numbers, and I want to XOR those 100 numbers.
I know.
Yeah? Why? Yeah? How can you, is there any faster way? Is there a faster way you can get this is 0 or this is 1?
If the amount of ones is even, then it's a 0.
That's right. That is correct. So basically, this is just to calculate how many ones you have. If you have even number 1, it's going to be 0. If you have odd number 1, you're going to have 1. All right? So this is correct. This is correct. You just calculate the numbers of ones, the number of ones. All right? Why? Because besides the number of 1, everything is 0. Everything is 0. Right? If you have 1, 1, then you are using this 1, XOR the 0, it's going to be 1. Right? X1, if you have 1, 1, and the XOR the other 0, you're going to have 1. If you have 2, 1, it's going to be 0 again. And 0 XOR other 0 is always 0. So 1 means every time you see 1, you are going to flip the sign. Okay? If you see 1, it's going to be changed to 0. If you see another 1, it's going to be changed 1. So basically, you see 1, it's going to be 1. If you see 1, 1, it's going to be 1. If you see 2 ones, it's going to be to 0. If you see 3 ones, it's going to change to 1 again. So basically, you just calculate the number of ones. All right? If you have thousands, many numbers doing the XOR, you just calculate the number of ones for each digit. And you can calculate, if it is even number, it's 0. If it is odd number, it's going to be 1. It is a faster way. All right, so this is XOR. So we will see a lot of very interesting problem using those bit operations. Okay, so any questions here? So any question? Okay, if we don't have question, I'm going to continue. So the next topic is about the shift operators, the shift. So what is a shift? So shift has 2 shifts. One is called L shift, one is called R shift. So L shift means I'm going to shift. This X is a number. I'm going to shift, let's say this is 3. I'm going to shift this digit. So let me see. I'm going to shift this digit to the left by 3, okay? So I'm going to shift. I'm going to do the right shift, just like 123, 45. If we are going to left shift, okay? If you're going to left shift one place, you're going to get 1, 3, 4, 5. And this one is out, okay? This one is out, and you are going to filling with just a 0. Okay, because you can see this is like, I'm going to shift to the right. It's going to be 2,345, and it's coming to 0. All right, or you can, if they have 0 in front, you can shift this one as well. Okay, so this is left shift. This is left shift. You just switch this all numbers to the right, to the left. But if you do not have enough, let's see. If you do not, let's see, you just have 7 numbers. You just have 7 numbers and you want to shift, and the numbers will be like, get lost. Okay, if you left shift 3 numbers, if you only have seven digits, if you only have 7 digits and you want to shift this 7 digits number to the left by 3, and the first 3 will get lost, then it's going to be 1 0 1 1 0, and the other 3 you are going to fill in with 0. Okay, you are going to fill in with 0. All right, but if you have more space, let's say you have 7. You have 7 digits, let's say 1 0 1 1 1 0 1, and you have additional space, but at the beginning those spaces are all 0. And now if you are going to shift by 3, then everything shift by 3. All right, everything shift by 3, and this 2 are 0, and this is going to fill in with 0. It all depends if you have enough space to the shift. If you do have enough space to shift, you shift everything to the left. If you do not have enough space to shift, you are going the leading several digits will get lost. All right, the leading several digits are going to get lost. So this is L shift. The right shift is basically the same thing. You just shift to the right. You just shift to the right. But you can see this is the unit. This just like the decimal is unit. You cannot shift more, right? Because this is the last position. You cannot shift more. So in this case, if you do the right shift, if you do right shift by 1, then this number get lost. If shift by 2, this number get lost. If you right shift by 3, this number get lost. And the leading one, so let's say 1 1 0 1 1. You have 5 numbers, and you are going to right shift by 2. Then this 0 become to here, and this one become to here. This one become to here because you right shift 2, and the leading one will be filling with 0. All right, the leading one will be filling with 0, and this 2 1 get lost. Okay, so this is the left shift and the right shift. Okay, and let's see. So let's see if I have a number. So this is the decimal. If I have a number decimal 5, so 5 in base of 10 is equal to what? Is equal to 101 in binary, right? I think it's correct. 101 in binary in binary. Okay, if I left shift this by 1 position, okay, so usually this left shift you will see left shift by 1 position, so you are going to add a 0 here. Okay, you are going to add a 0 here. So what's the decimal number for this? What is the decimal number for this? So this is in binary. So what is the decimal number for this in base of 10? You can see this is 0, and this is 2, this is 0, this is 8. So basically this is 10, right? 10 in decimal in base of 10, right? So this is like left shift by 1. How about you shift again? You shift again, so you are going to get 1 0 1 0 0 in decimal. Sorry, in the binary. What is the number in base of 10? What is the number in base of 10? This is 0, this is 0, this is 4, this is should be 8, but 0, this is 16, this is actually 20. All right, this is actually 20. So if I shift again, I'm going to get 1 0 1 0 0 0 in decimal. What is the value here in base of 10? Anybody? If you find the pattern, what is the decimal in base of 10? You can see this is 0 2 4 8. This is 8. 16 32. This is 32. 32 plus 8 is 40. All right. Did you see any pattern? Did you see any pattern? Every time I left shift, if I do have enough space, okay, if I do have enough space. If you do not have enough space, that's another story. If you do have another space, if you have enough space, when you left shift by 1, it's just like what? You can see this is 5. If I shift by 1, I'm getting 10. If I shift by 1 again, I'm getting back at 20. If I left shift again, I'm going to get 40. If I shift again, what's the number? Let's say I shift again. 1 0 1 0 0 0 0 is equal to what? Without calculation, What is this number without calculation? Anybody? Yes, that is correct. It is 80. All right. So if I shift again, do you need to calculate? If I shift again, it is 160. All right. So if you do have enough space, the left shift is just like times 2 in the decimal. Okay, it's just like times 2 in decimal. This is actually very, very similar. So if I have 123, if I left shift by 1, I'm just adding 1 0, right? So it's times 10. If I have 123 in decimal in base of 10, if I left shift, I'm adding a 0. It just looks like times 10. But if I shift again, I'm times another 10. If I shift again, I'm times another 10. So every time I adding a 0, it's just like times 10 in decimal, right? But in binary, every time I adding a 0, it's just times 2. Okay, it's just times 2. Does that make sense? Every time I adding a 0, it's just like times 2 in the decimal. All right, it's very simple. Okay, so if later, if you see left shift, if you do have enough space, it's just like the times 0. How about the right shift? How about the right shift? So basically right shift, just to remove 1 0, just to remove the last number. The leading number will be filling with 0. I just remove the last number. So if you right shift by 1, it's just like divided by 2. Okay, just like divided by 2. So let's say if you have 10, so the 10 is 1 0, it's 1 0 1 0, right? So this is 2 4 8. Yeah, it's 1 0 0. If you right shift by 1, you are going to get 1. So this is 10 101. So 101 is basically 5. If you shift by another right shift by another 1, you are going to get 1 0. So 1 0 is basically just the 2. Okay, it's basically 5. If you are using 5 divided by 2, 5 divided by 2, you are going to get 2. So basically, right shift is just like a division. Okay, but it's like it's not this, it's this. Okay, it's this. It's just like division. If it's if odd number, you are going to get the lower number here. All right, 5 divided by 2, you're going to get a 2. Okay, if 4 divided by 2, you're going to get a 2 as well. So right shift just like divided by 2. Right shift just like divided by 2. Left shift just looks like the times 2. All right, so this is called the left shift and the right shift. But if you do not have enough space, as I said, let's see, I only have 8 positions. Then if I left shift by 2, so I'm going to left shift by 2. So basically, I'm going to just remove this 2 because I do not have enough space. I just remove this 2. Then I'm filling all the numbers. And at the end, I'm going to fill in another 2. Okay, I'm going to fill in another 2. All right, so this is called the shift, left shift and the right shift. Okay, and there's another one called circular. Circular shift. This should be L. So circular shift. Circular shift just looks like those numbers are in a table. Okay, those numbers are in a table, and you circular shift. You can left circular shift by 2, or you can right shift circular by 3, etc. So for example, you have 1 0 0 1 1 0 1. So now I'm going to circular shift by 2. So now everything shift by 2. So you are going to get 0 1 1 1 0 0 1 1 0 and 1, right? So basically you are going to shift these 5 numbers by 2, and then you are going to add these 2 numbers at the end. All right, and you are going to add these 2 numbers to the end. So this is called left shift by 2. Okay, left circular shift by 2. Okay, so basically by 2, first you remove these 2 numbers and add those numbers at the beginning and add these 2 numbers at the end. This is called the left circular shift. And the same thing for the right circular shift. Okay, the right you have 1 1 0 1 1 0 1. You are going to right shift by 3. So circular right shift by 3. So basically you are going to remove this 3 Now you are going to get 1, 1, 0, 1, and adding these three numbers in the front. All right, so first you just remove this 3 and move those 4 numbers right to the right by 3 positions, and then you add back this 101. Okay, so this is called the right circular shift and the left circular shift. All right, so any question? Any question? Okay, do not have questions. All right, so this is the shift example. So you can take a look after class. So this basically is just the example from the wiki page. So you can look at this should be correct. Okay, so it must be correct because I copy pasted this table from the wiki page. So you can take a look. All right, and the last part is called order of precedence. So as a similar, so we evaluate the parentheses first. We evaluate the parentheses first, and then the shift and the circular shift has higher priority. We are going to evaluate them first, and then the AND, okay, and then the AND, and then XOR. The OR has the lowest, okay. So you have to memorize. During the contest, you have to memorize this order: parentheses, shift, and the circular, okay. The shift and the circular shift, and the AND and XOR and OR, okay. If they do have the same level, so let's see if I have A and B and C and D. If I have the same level, you can see everything has AND. They have a same level, then you evaluate from the left to the right. Okay, if you do have the same level, you evaluate from the left to the right. Okay, so this is the order. It should be very simple, but you have to memorize this order. All right, so now let's do some exercise, do some practice. So this one, the first one, 1 0 1 1 1 0 and not 1 1 0 1 1 1 1 0 or shift. So you can see first I have to do what? I have to evaluate this. I'm going to, so in the ACSL competition, they do not have enough space. All right, they do not have enough space. So when you shift this by 3, so when you shift this by 3, so basically you're going to remove this 3. And you are going to get 0, 1, 0, and filling all the 0. All right. So if you evaluate this first, you are going to get 0, 1, 0, 0, 0, 0. All right. So this is the step, the first step. And second, you have to evaluate the not, right? Let's go back to the previous slides. You have to evaluate, oh, I do not put the not here. So not should have the not should have a higher priority. Okay, you should evaluate the not here. I have to add this not at here. You have to add not. The second is you're going to evaluate the not. So if you evaluate the not, it's going to be 0 0 1 0 0 1. All right, and then the next part is easy. This and this, okay, and then all this, and this and this is 1 0 1 1 1 0 and 0 0 1 0 0 1. All right, and you're going to do the AND. So this is going to 0 0 0 1 0 0. You are going to get this, and at the end you're going to OR this. So you have a 0 0 1. So this is 0 0 1 0 0 0. So the end, the result will be 0 1 1 0 0 0. All right, so it should be very simple. Okay, just be very careful. Okay, so first you know the order, and then you just evaluate one by one. So the next one is very similar. So those are all have parentheses. Then it's very easy. I have to evaluate this first. Right circular. Okay, right circular. I have to remove this two and 0 1 1, and I append this in the front. Okay, it's become to 0 1 0 1 1, and now I have to do this left circular. This left circular by 4. Okay, so I'm going to remove this 4. I'm going to keep this 1 only, and 1 0 1 0 1. All right, so this is the second step, and the last is right shift by 1. Right shift by 1 is simple. So so I'm going to change this, right? This one, right shift by 1 will become to, I'm filling 0 at the beginning, 0 1 0 1. I'm going to remove this one. All right, so and so this is the results. Am I right? Should I work on this? I forgot. Should I work on this or this? Maybe I should work on this, right? Yeah. I should work on this. Yeah, so this number is my let me see, the right circular. Yeah. So this is the first step. This is my first step results. This is my second results. And my third step results should be based on the second step results. Then right shift by one, then I should get 0, 1, 0, 1, 0. All right, so this is the final results. This is final results for the second question. All right. Okay, so the next two should be similar. I'm giving you 2 minutes, okay? 2 minutes for each questions, and let me know what's your results for the next two. What's the result for the third question? What's the result for the third question? I see one answer. I only see one answer. I see another answer, but I got two
Sorry
different.
about that. I typed it very quickly, and I suddenly realized that I just typed it way too quickly.
Okay, and you can correct your answer. Okay.
Yeah, sorry about that.
That's okay. So now I got two same answers from you. Okay, I got two same answers. Anybody else? I got three same answers. How about the others? Any questions? Any questions? So this one, I should evaluate this first, right? It should be simple. After I evaluate this, then I should evaluate this not. So that be right. This is the first step. And then this is the second step. And now I have and or and and. So as we discussed, this and has high priority. This and has high priority. I should evaluate this as third step. And the last, I should evaluate this. All right, so this is the fourth step. Okay, so I got 1, 2, I got 1, 2, 3, 4. I got 4 answers, so 4 same answers. Okay, I got 1, 2, 3, 4. Yeah, I got 4 answers, same answer, and pretty. So now I can see your answer is pretty good and is correct. Only 4. Any others? If you have any question, I'm not going to evaluate. I'm just tell you the answer. The answer is 1, 0, 1, 0, 0. Okay. If you get these answers, that's correct. If you don't get these answers, let me know. Okay. If you have any questions, let me know. Maybe you got some careless mistake, but it's okay. Yeah, let me know. Okay. So how about the last one? How about the last one? So last one, we should evaluate what? This, we should evaluate this first. And also we should evaluate this. We can evaluate both, right? You can evaluate this second. And now you have this. This is end, right? This is end. And this is the third step. And then this is the fourth step. And at the end, you're going to evaluate this, the fifth step. All right. So that's the problems. That's the question. Okay. So any questions? Any question?
I think I got number 4.
If you finish number 4, so let's evaluate number 4. Let's evaluate it number 4 together. So this number is what? This number is 0, 0, 0, 1, 0, right? So this right shift by 2, right shift by 2. So I'm going to remove this 2 and I'm going to fill in with 2, 0, 1, 1, 0, right? Okay, and now I have to do this end 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 1, and this number, right? And only this number are the same. Yeah, only this number has 1. All right, only this number has 1. So this becomes to 0, 0, 0, 1, 0. And now I have to do this or this. So this has 1, 1. This has 2, 1. So basically this 2 is become to 0, 0, 1, 1, 0. All right. And now I'm going to have this number 0, 0, 1, 1, 0. I'm going to left circular by 2. Left circular. I have to do this way, circular by 2. So basically 1, 1, 0, and 0, 0. I guess this is my answer. You got it correct? This number is the results. 1, 0, 1, 1, 0, 0, 0. Okay. So in practice or in the exam, the best way is just align them together. All right. To instead of my way is not good. So better way is to write the number. Okay. If you have 1, 1, 1, 0, 0, 1, you just align them. Okay. Align them, and this is the end. And now you have to know, okay? Prepare some scratch paper and only this is 1 and all others are 0. All right, so this is how I do those practice. Okay, should be simple. So any question? So any question here? All right, so I'm going to introduce some advanced topics. So those topics are not covered, should be not covered in the ACSL competition, but if you are interested in, we can talk about De Morgan's law. So De Morgan's law, they have the proof, and today I'm not going to talk about how to prove the De Morgan's law. We just need to memorize the De Morgan's law. Okay, so usually when I memorize the De Morgan law, I'm using this notation. I prefer this notation because it is simple. So when you see this, means or. When you see this, means and. When you see this, means not. Okay, when you see this, means not. So you have a big not. So you are going to evaluate A or B first. All right, you are going to evaluate A or B first, and then I'm going to apply the not on this one. So the not, you can see this not is pretty long. So that means that covered everything under it. That covers everything under it. So I'm going to evaluate A or B first, and then I'm going to evaluate a not. So basically it's A or B and not, okay? Something like this, okay? And this is equal to, I can split this not, okay? I can apply the not on A first separately, and I change this. I switch this from or to and then I have a not B, okay? So this A or B not, is equal to not A and not B, okay? We have to memorize those. So basically it's not too difficult. So basically if you have a big not, so I can just split it and convert this and then split it, this is not. And the same thing happens here. If you have and in the middle, when I split, I convert this, I just switch from not to or, okay? So basically if you have A and B and I have a big not, I'm going to switch this A or B. Okay, then sometimes it is easier. Okay, so for example, if I have something like this, not A and B, and I can have something not C if I have something big, something like this, then you also can split this, all right? You can split this because I'm going to evaluate what? I'm going to evaluate this first, right? So this is my first part. So basically, this is results. So let's call this result X. So basically, I have X or C naught, right? So I can convert this to what? Not X and not C, right? Not C is what? Not C is C, right? I can evaluate to something like this. Now I'm focused on the not X. Not X is what? Not X is basically this, right? Because I replace this with X. And now this is equal to what? This is equal to not A or not B, right? So basically this is A or not B and C because I have this, right? I have and C here. So basically I can convert this complicated thing into this. It's much, much simpler. All right, so this is called the De Morgan's law. De Morgan's law. So we have to memorize these two formulas. All right, so any question here? So this should not covered in the ACSL competition. Yeah, but if you are interested, you can try to memorize it. And there have tons of proof, how to prove this De Morgan's law, but it's not necessary. Okay, you just need to know this. Okay, De Morgan's law. And also we have some fancy skill. I'm not sure if we have time. I'm not sure if we have time to the fancy skill. I'm going to just show you one question. Okay, I'm going to just show you one question. We can use the bit operation to do a lot of things. Okay, we can use the bit operation to do a lot of things. So let's see. I have a list. I have a list. So this list contains all the numbers from 1 to n. Okay, so this n is the input. Let's say this n is, I'm going to say this n is, I'm having a list. This list covers all the numbers between 1, let's say to 10,000, okay, from 1 to 10,000. But there is only one number missing. There is only one number missing. I don't know which number. There is only one number missing. And this list is not sorted. Okay, let's say the first number is 5. The second number is 999. The third number is 3. The fourth number is 10,000, right? 5,937. Blah 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 blah. I have total. Let me change this. I'm going to just 1,000 numbers. I'm just change to 1,000 numbers. I'm going to change this to 900. Okay, so there are total 999 numbers. Okay, because all of these numbers covers range from 1 to 1,000, but there is only one number missing. I don't know which number is missing. Okay, I don't know which number is missing, but I know for sure there is only one number missing. Okay, that's why total I have 999 numbers. And my task is to find out this number. Okay, my task is to find out this number. How can I find this number? How can I find out this number? Anybody? They have at least 4 or 5 solutions. So let's see who can find the first solution. How can I find this missing number? Nobody? Anybody? I have 999 numbers, covers the range from 1 to 1,000, and there is only one number missing. My task is to find that number. Anybody has any solution? No one? Okay, nobody has any solution? So how about, okay, how about if, the first solution, if I sort this array, okay, if I sort this array, so let's say 1, 2, 3, I sort this array, okay, the first solution is if I sort this array first, and then I can go one by one, right? I can go, this is 1, this is 2, this is 3, this is 4, and this is 539, and the next one is not 541, because I sort this list. I sort this list, and this number is 539. The next number is 541. Am I finding the missing number? Am I finding the missing number? Yes, right? So this 540 is the missing number, right? Is this a solution? If I sort this array, I can sort this array, right? So this is the first solution. I sort this array, and then I'm going to just search one by one, and then I can find this number. So this is the first solution. How about the second solution? I still can sort this array. Okay, I still sort this array, and then what? And then what? I'm going to find the middle values. From 1 to 1000, the middle value is 500. If this number is 500, what does that mean? That means on my left-hand side, I do not miss any number on my left-hand side, right? So let's see, if the missing number is on my left-hand side, so this number should not be 500. It should be 501, right? Because they are missing one number, and you have filling that number. You have filling that hole. So every number will shift to the left, right? Every number will shift to the left. Then what? So this middle number should be 501, right? So, but this number is 500. That means the missing number is not on my left-hand side. The missing number is on my right-hand side. I just go to the right-hand side to find it. So now I'm going to search 750. I'm going to search 750. Is because I find the middle number from 500 to 1000. I'm going to find 750. If this number is 750, what does that mean? If this number is 750, that means on my left-hand side, I'm not missing any number, the same thing, right? If the number is 751, so this is the missing number. This is the missing number, all right? So I can do this is called the binary search. I can do the binary search. First, I sort this array, and second, I'm going to do the binary search to find the missing number, okay? So this is the second solution. And the third solution, what's the sum from 1 plus 2 plus 3 plus to 1000? What is the sum? 1 plus 2 plus 3 plus to the 1000. That means what's the total sum from 1 to 1000? Anybody know? What is the sum from 1 to 10?
Is it 1001 times 1000?
Yeah, so it's 500. Okay, the sum of the first 1000 numbers, the sum is 500. Okay, so I can get this number, and then what? And then for all these numbers, can I calculate the sum for all these numbers? I can, right? I can calculate all the numbers, all the sum for all these numbers. And then I use this number minus this sum. This is pure math, right? I can use this number because if there is no missing number at all, the sum from 1 to 1000, I'm getting this number. But there is missing number. I just calculated the sum for all these numbers. Then I use 500 minus this sum. I can find the missing number. So this is the third solution, right? So now I'm talking about the most fancy solution, okay? So let's assume I have only 1, 2, 3 to 10. Let's assume I have only 10 numbers, 1 to 10, all right? Only 10 numbers, and there is a missing number. That's it, that missing number is 8. I'm missing 8. What can I do? What can I do? I can do the XOR. What is XOR? XOR, let's see, 1 XOR 2, what is this number? So when we do the XOR, when we do the bit operations on the integers, they actually convert those integers to the binary. Okay, we learned this, right? We learned this in our first lecture. We convert those into the binary. So this 1 means 0, 1. This 2 means 1, 0. These are binary. And then after we convert the, so we are not going to convert the binary. The system, the Windows, not Windows, the computer will convert the binary for us. When you do the XOR, they actually do the bit operation on every single digit on the binary. Okay, this is 0, 1, this is 1, 0. So they are going to do the XOR on those binary. So this one is going to be 1, 1. All right. So when you do the XOR on the integer, they are going to apply this XOR operation on the binary. So 1 XOR 2 is actually 1, 1. It's actually 1, 1. All right. So let's see, I have a number. Let's call this number A. I'm going to do A XOR A. Basically, I have an integer number. I have another integer number, but they are same. Okay. A XOR A. What is the value? What is the value? So let's see. The A value is 1, 0, 1, 1, whatever the value is, right? What the value is. But I'm doing same thing. So you can see XOR means what? XOR means I'm going to apply on every single digit. If the digit they are the same, I'm going to set to 0. So A XOR A, every single digit is 0. So that means A XOR A is 0, right? A XOR A is 0. So how about A XOR 0? How about A XOR 0? So let's see. If I have number 1, 0, 1, 1, I'm going to XOR 0. You can see 1 XOR 0 is 1. 1 XOR 0 is 1. 0, 0 XOR 0. So you can see this is A, this is 0. A XOR 0 is also A. It doesn't change. Okay, it doesn't change. A XOR A is 0. A XOR 0 is A. And then what I can do. So let's see, I only have 10 numbers. I only have 10 numbers. Okay, so now what I'm going to do is something like this. And also we talk about the commutative law and the associative law of XOR, right? They support this. So that means A XOR B XOR C is equal to B XOR A first, and then XOR C, right? You can change the order. The order doesn't matter. You can change the order. So now what I'm going to do, I'm using this. So XOR, I'm going to use this annotation as XOR. So what I can do is 1 XOR 2, XOR 3, XOR 4, etc. XOR 10. I'm going to XOR all the numbers here. And then my list has 9 numbers, right? Remember, my list has 9 numbers. I'm going to do the XOR on those 9 numbers. Let's see, 8 is missing. So now I'm going to A1 XOR 2, XOR 3, XOR 4, because the 8 is missing. I do not have 8 here. I do not have 8 here, right? I do not have 8 here. So basically, I'm going to XOR from 1 to 10, and I'm going to XOR every single number in the list, in this list. Then what? Because this law, I'm going to do is actually 1 XOR 1 is 2. 1 XOR 1 is 0. 2 XOR 2 is 0. 3 XOR 3 is 0. 4 XOR 4 is 0. 10 XOR 10 is 0. And anything is cancelled out. Anything is cancelled out, except in the first list, you do have the 8. But in the second list, you do not have the 8. So the 8 will be left over, right? The 8 will be left over. And now it's just like X 0, 0, everything 0. And XOR 8, you are going to get 8. All right, you're going to get 8. So this is the fancy thing to find the missing number. I'm using the XOR. Okay, it's actually very similar to calculate the sum, but I'm using XOR operations. All right. So it's kind of hard. Because the time is very limited. It's kind of hard to explain clearly. Okay. All right. So we have like maybe 10 more minutes already. So I'm going to stop at here. So any questions? Yeah, any question? All right, okay, so if you do not have questions, that's all for today's class. I'm going to upload this slides into, yeah, I'm going to share these slides using the Google Drive, and I'm going to upload this video tonight to the YouTube. Okay, thank you. Bye-bye.
Bye.
Okay, bye-bye.
Thank you.